Alright, I'm recording. If I can get your attention up to my screen, please. I know y'all are in groups. If y'all can just look forward. Turn your desk if you need to. So, today we're going to be talking about addition, subtraction, multiplication, as well as unit vector and magnitude. If vector A is A1, A2, and vector B is B1, B2, and they are vectors, and K is a scalar, then the following are true. When you are adding vector A and vector B, you would take the x component of vector A plus the x component of vector B and add them together, comma, the y component of vector A and the y component of vector B, add them together. Same thing for subtraction, you would just subtract them. If you have a scalar k, you just distribute that to the x and the y component and multiply. So, I have vector w is negative 4, 1, vector y is 2, 5, and vector z is negative 3, 0. How would I add vector w plus vector y? How would I add negative 4, 1 plus 2, 5? Add the x's, add the y's. So what am I going to add? Negative 4 plus 2, comma, 1 plus 5. And what is that going to give me? Negative 2, 6 is my answer. Do y'all agree we kind of did that yesterday with vector u and vector v? Okay. What if I had vector z minus 2 vector y? What is vector z? Negative 3, 0. Minus, what is 2y gonna be? 4. Okay, so here's where just be careful. You can either just multiply it by 2, which is what I'm about to do. If you multiply it by negative 2, make sure you don't also subtract them, because then you have a negative and a negative, which ends up being a positive. So just be careful. I always leave it minus, and I'm just going to multiply it by 2. So this is going to become 4, 10. Does that make sense what I'm doing? And then I'm going to subtract them. Your x component minus your x component, your y component minus your y component. And what is my answer? Negative 7, negative 10. Do you guys agree? Yes. Yes. How did I get 410? Because do you see how it's 2y? And do you see how y is 2, 5? And just multiply them. Yep. That makes sense? All right. I don't laugh. Mm-hmm. Oh. I can't hear anything. The fan's in my face. All right. C. It has 2 vector w plus 4 vector y minus vector z. So, what would 2 vector w be? Negative 8 and 2. Just multiply them by 2, right, Edwin? 2 vector w, just multiply those by 2. Yeah. What is 4 vector y? Say it again. You have to speak louder. I cannot hear. Thank you. And then minus, I'm just going to write vector z, which is negative 3, 0. Now, because this has 3 different vectors, your x component and your y component, you're going to have 3 different numbers. So, what is negative 8 plus 8 minus negative 3? What is 2 plus 20 minus 0? Does everybody see how we're doing all the x's and then all the y's? And this is going to give me what? Be careful. Positive 3, because a negative and a negative is a positive 3, comma, 22. So this vector would go right 3 up 22. Okay, no tests over this, just an assessment. You're welcome. I don't know yet. Maybe. I try to. Alright. A vector has a magnitude of 1 unit. We call that the unit vector. It is sometimes useful to describe a non-zero vector v as a scalar multiple of a unit vector u with the same direction as vector v. And to find vector u, we divide vector v by its magnitude. Now, let's say we have a vector, just any vector. Do you agree we can use distance formula to find that magnitude? If that magnitude is not 1, you can find the unit vector using this equation right here. Yes. Distance. And that's what this symbol is right here. This is asking for the magnitude. So, I'm going to change problem A just to make our lives a little easier. And I'm just going to change that 2 to a 4. Can everybody change that -2 to a -4? That way we just want an easier life today. So, what am I going to do first to find the unit vector? Well, the unit vector is vector v over what? Over the magnitude. I have to find the magnitude. So, right below here, I'm going to find the magnitude of vector v. Now, how do I find magnitude? I told you it was distance, but how do I find it? A squared plus b squared equals c squared, essentially. It's Pythagorean theorem. It's x squared plus y squared equals r squared. You take your x component, square it, plus your y component, and square it. Normally it's cold when y'all come in every day. Is it not hot in here today? It is hot, right? I wonder if the AC's out. Because this room is not usually this hot 6 period. And what is -4 squared plus -3 squared? 25. And what is the square root of 25? So my magnitude is 5. Write it down, please. So to find the unit vector, I'm going to take vector v, -4, 3, and divide it by that magnitude I just got, 5. So what is my unit vector going to be? -4/5 and 3/5. You are going to have to remember that equation. I will review that equation with you before the assessment. Yes. The Friday we get back from Thanksgiving. Alright, let's try B. I'm not going to have you try it on your own because it's a little complicated, but let's try it together. What am I going to do first to find this unit vector? Magnitude. What is the square root of 40? 2 root 10. Because it's 4 times 10. Then I divide my vector by that magnitude. And what am I going to get here? We are going to have to. Before I rationalize it, let's reduce it. So what is 6? It's going to give me 3 divided by root 10. Do y'all all agree with that? And then what's the other one going to be? Negative 1 over root 10. Now you're right, that's not acceptable, so I am going to have to rationalize it. And what am I going to get? You are only using this equation and doing this if I say find the unit vector. What questions do I have? None? All right, the unit vectors in the direction of the positive x-axis and positive y-axis are denoted as vector I is 1, 0, and vector j is 0, 1, respectively. Vector I and j are called standard unit vectors, and these vectors can be used to express vector v in component form AB as a vector I, j, b vector j. We talked about this yesterday at the end of class. Do y'all remember me telling y'all that? Yes. So this right here we call component form. This other one with vector I and vector j is the linear combination form. They are just different ways to describe vectors. So if I had 3, negative 4, I could rewrite that as 3 vector I minus 4 vector j. Ava, you with me over there? Some things to note. There is no comma in linear combination form. So if you put a comma, you'll get points off. There needs to be a plus or a minus sign, depending on if that second number is positive or negative. Also, your I and j need to have the vector symbols above them. If you forget that, you'll put points off. By the way, your vector symbol only goes above the I, not above the 3i. Some people try to do that. So, let's do what we did yesterday and combine it. If I give you 2 points, how do I write vector DE as a linear combination if I know D is negative 2, 3 and E is 4, 5? What am I going to do? This is what we did yesterday. How do I figure out this in component form? x2 minus x1, comma, y2 minus y1. Y'all remember doing that yesterday? By the way, I honestly prefer to do everything in component form and then at the very end change it to linear combination form. To me, this is just a lot more writing and unnecessary if I can do it in this way. The only problem with that, and you'll see, you're going to have to call me out on it, I sometimes forget to change it at the very end. So that's the only bad thing about switching over to component form is if you don't remember, you'll get points off because you don't switch it. So just, I'm always going to do component, at the very end switch them. You can do either one. So this is going to be x1, y1, x2, y2. Do you have to go in this order? Yes. Why do you have to go in this order? Because which way does the arrow go?
Left to right.
Yeah, you have to make that your D is your initial point, your E is your terminal point. That matters because that determines the direction of your vector. So what am I going to get here? 6, 2. But again, that's not my answer. What's my answer going to be? 6 vector I plus 2 vector j. Because it says write it as a linear combination of I and j. Thank you. Got a whole 3 degrees for it. Just so you could tell me I was smart. I want you to do example B. Go. You don't think it's ridiculously hot in here? Y'all do? I'm going to turn on this fan. It's an air circulation. Tell me if it's too strong. So if I give you a quiz on yesterday, you got it?
Absolutely not. Somebody I got it. I already got it.
I mean, this is like half of what we did yesterday. What did you get? -4, 9. But make sure you wrote it as -4 vector I plus 9 vector j. Does everybody have that down? Okay. Turn your paper over, please. Why they're trick questions. So what I told first period, if you look at the back, yes, you are going to need to know your unit circle for this assessment. The good news is what I'm going to show you is the only reason you're going to need it, so it's not a lot, I promise. You'll be like, okay, it's not so bad. After everything that y'all have done, this is cake for your unit circle. All right, number 4. This is what you're going to see on a section of your test. Actually, all of these are test questions, assessment questions. Do you notice how I give them to you in linear combination form? I personally don't like working in linear combination form, so I am going to switch these to component form. And I am going to work in component form. Could you write everything in linear combination form? Sure, you do you. That ain't me. So, how am I going to do 2 vector v plus w, vector w? 4, -6. I multiply that vector v by 2, plus, what's my w? -4, -2, or positive? -2. And as a reminder, because some of us already forgot, how do I do this? Add what? Make sure you're adding your x's and your y's. A lot of y'all like to do this. Let me add these two together. Don't do that. Add your x components. Add your y components. What do I get? 0, -8. Now, how do I know which form to do? Whatever I give you That is what you need to give me an answer in. I gave you in linear combination form, so your answer should be in linear combination form. Now, I would accept either one of these. This one is probably how I am going to answer it, but if you gave me 0 vector I minus 8 vector j, that's still correct. But I would simplify it. Well, what's 0 times anything? I'm right. What's different about B, C, and D? They are magnitude. What do we know about magnitude? What is magnitude? Oh. They are finding distance. How do you find distance? A squared plus B squared, square root of. It is. I don't know what's happening. I wish we had windows. Oh, thank you. Thank you. Look. The humidity distracted me. Alright, let's do that again. What do we got? -4 and -2. I was just testing to see if y'all are paying attention. Clearly you were, some of you. Did y'all get square root of 20? But that's not my answer. What's my answer? 2 root 5. Magnitude will always just be one number. Or 2 root of 5 is one number. If you could stop, that'd be great. Alright, what is the difference between C and D? They're both subtracting. What's the difference between C and D?
For C, you find magnitude from each one separately.
So for C, you're going to have to find two distances and subtract them. What about for D?
You do the first part and then you do that.
Subtract first. Subtract your vectors. Then find the distance. That was a gulp, right? Okay, so I'm going to find the vector V, because I haven't found that yet. I was trying to, but y'all told me I was wrong earlier. Find vector V. And do y'all agree we already found vector W and the one above it? And what do I need to do to them?
Subtract.
Y'all, you literally can't do anything else. You just leave them like that. Write it down, please. Kylie, you with me over there? Ava, you with me over there? Wake them up. Throw something at her. Can you scream? No. You want ice cream?
Yes.
Alright, for vector, or for number D, letter D, what am I going to do for this one? Let me subtract these vectors. What is vector W? V minus vector W. Hello.
Talking about some thank you, bro.
Thank you, thank you. Okay, perfect.
Thank you, bro. No one really talking about some thank you. I'm just kidding, girl. See, you saw that? He smiled when he saw me.
Did he? Good. Okay. All right. Vector v minus w. What's vector v? Minus what's vector w? Subtract them. What is 2 minus negative 4? What is negative 3 minus negative 2? Six what? It's not. Negative 1. Thank you. I'll be so ready for when y'all move on to something else. Did we talk about the test in this class? Did y'all find a ridiculous amount of that number on the test?
Oh, yeah. Did you do it on purpose?
I didn't do it. I didn't make it. But no, I don't know because we've had that test for like years. So.
Wait, miss, was that last question supposed to be really easy?
Yeah.
It was just area.
Because I worked
Yeah.
backwards. I thought I was tripping.
Tell me why so many people left it blank.
Gabriel.
Alright. How do I find the magnitude of that? I'm going to take this subtraction
6 squared.
and do 6 squared plus negative 1 squared and square root it. Y'all, what is negative 1 squared?
1.
Are you sure? You are definitely going to see probably all 4 of those questions on your assessment.
How many questions is there on the assessment?
Oh, that's a good question.
4.
I have no idea.
Is it just gonna be like worksheet or like that's why?
It's going to be like we call it the animal race. I don't know why we call it that, but I do know why, but it has nothing to do with that.
It's color papers?
The color papers where you come up to my desk, yeah. Again. We call it an animal race, but... What?
That assessment.
Yeah, I like those assessments.
You should do all the tests. No? Based on who you're sitting next to.
No. Alright. A way to specify the direction of a vector v is equals AB is to state the direction angle theta that vector v makes with the positive x-axis. By using the magnitude and direction angle of the vector v, it can be written in component form or in linear combination form. The form we are going to look at, or that these are all the same things. This is just in component form. This is in linear combination form, and this is just before you distribute it. I'm usually going to do this one right here. Use that as like my formula. So, if you are given the magnitude and direction, can you find the vector? That's what this is saying. So, I gave you the magnitude, I gave you the direction. How do I find the vector? You use that formula. Vector v is your magnitude times the cosine of theta, comma, your magnitude times the sine of theta. No parentheses. Chevron. With Techron. Just kidding. What is the cosine of 120? Look at who's with it over there. So 10 times negative 1/2. What is the sine of 120? It's in the second quadrant, so your x should be negative, your y should be positive. And that gives me what? Negative 5, comma, 5 root 3. And that is my answer. Does that make sense? That's really all you're going to need to know your unit circle for. You'll have a dry erase marker. You can write it down in the corner if you need to. I didn't read the instructions, did you? What do they say to do? It said to do it both component form and linear combination form. It's not. I would turn this one on too, but again, I can't hear because it's so loud. I want you to do B. Go. What's the cosine of 45? I'm making what? I'm making Coy angry? Why am I making him angry? Did you do that?
We almost got there.
How'd you not get there?
I forgot my unit circle.
Oh, 45? Come on. Come on, that's the easiest one. What is 8 times the square root of 2 divided by 2?
4 root 2.
So this is 4 root 2, comma, 4 root 2. Or 4 root 2 vector I plus 4 root 2 vector j. So you would use this when you are given the magnitude and theta. This is how you find your vector. So we've learned how to find vectors given 2 points. We've learned how to find vectors giving the magnitude and theta. And we've learned how to find the magnitude. Can I move on? Sure.
We have a review.
That's what your homework is. It literally says review. Alright. Can I move on? Is there a trash can right there? Did I make it?
Careful.
Alright. Number 6. And the number after that are the same type of problems. Find a vector v whose magnitude is 4. Box that. And whose component in the I direction is twice the component in the j direction. Word problems, your favorite. Alright, look up please. Do you agree normally we have a vector I plus b vector j, or something like that? If my I component is twice the component in the j direction, what do we know about these components? The x is going to be 2 times the y component. So do you agree I could say, hey, this is the y component, and my x component is going to be not 2x, 2 y's. Do y'all agree with that? You could do 2x and x. First period, I did 2a and a. Like, it doesn't matter what you do. But this first one has to be twice that one. Yeah, and they have to be the same letter. All right, so what else do I know? The magnitude. What is my magnitude? 4. And how do I find magnitude? the square root of a squared plus b squared. In this case, what are my a squared and my b squared? 2y and y. Because that's a, that's b. Okay, what now? Square them. What is 2y squared? 4y squared. What is y squared? And what does that give me? So 4 equals the square root of 5y squared. Am I going too fast? Please write this down. What now? No. I mean, I get what you're saying, but there's an easier way first. Square both sides. Square both sides. And then? And then do y'all agree I get y squared equals 16 over 5? I know I just went very fast on all those steps. Do I have any questions about any step I took? Does everybody get why I have 2y and y here? And how that transferred here? Okay, what next? And when I square root both sides, what is going... I'm going to square root the top and the bottom. Plus or minus, what's the square root of 16? 4. And the square root of 5 is going to stay the square root of 5. I do need to rationalize. So my y is going to equal plus or minus 4 square roots of 5 over 5. Now we have to go back over here. What's my x going to be? Why is my x going to be 8 root 5 over 5? It's 2 over 1, you multiply it. And we know my y is 4 square root of 5 over 5. And we have to put it in linear combination because that's how it talked about it. Now, when you put this in linear combination, it is going to be 8 root 5 over 5 vector I plus 4 root 5 over 5 vector j, and negative 8 root 5 over 5 vector I minus 4 root 5 over 5 vector j. Why is it both of these, and why can I not just do plus or minus?
Because it's going in both directions.
No? What did it say it does? It's twice. So if you multiply your this value by the positive, you're going to get a positive. If you multiply this one by the negative, you're going to get the negative. You can't have one positive, one negative. What questions do I have about this word problem? It is a little weird. Edwin, did you give up on me? Not yet. You sure? Okay. Questions? All right, last one I'm going to have you do on your own. The magnitude is 3. And the I component is equal to the J component. Meaning what? They're the same. So whatever you... Oh, look. The AC is down. Whatever you get in the first box, you're going to get in the second box. All right, go for it. Do it. See what you get. No, I have a degree. I don't have to.
I have a degree.
That's gonna be my thing today.
Fahrenheit.
I got a degree. I spent so much time in school
Maybe you should go to school.
to do what I want now. It's wild. Well, who did that?
Joy.
Why don't you go? What'd you get for your equation? Make sure you write both answers in linear combination form. Did everybody get here at least? And then if you square root both sides, you should get x equals plus or minus 3 square roots of 2 over 2. Yeah? So what are your two equations? Don't forget your vector I and vector j. And then don't forget the negatives. Y'all want to learn dot product? I think we'll save that till after Thanksgiving. I could teach it tomorrow, but like,
Miss, what are you doing for Thanksgiving?
I'm doing a whole lot of nothing. What? Yeah.
Thank
But we'll learn it when we come back.
you. Can we do that next week?
Alright, your homework is to do all the review.
The entire?
The entire thing.
Why are we like